Hello, welcome to the Rainbow Dash Template tutorial. Here you will learn about the Rainbow Dash templates. This video will introduce how to implement the effect of the obstacle mechanism. Alright, let's get started. In the template, obstacles are constantly generated on one side of the scene and moving towards the other. Players need to dodge moving obstacles and stand in the designated region to increase progress. When the progress reaches 100%, the player passes the level. If the player did not avoid the obstacle, they would be hit by the obstacle and fall back for some distance. This video will only implement the logic regarding obstacle generation, obstacle movement, and obstacle collision with the player. For the logic of increasing the progress of the player in the specified region, you can watch the tutorial of Spotlight mechanism. The logic of increasing the progress for both of them is the same. Next, let's prepare some obstacles first. We can use the part modeling tool to make some obstacles. For example, after building a suitable obstacle, select all the parts in the game resources view, click Union, and you have finished making an obstacle. We can adjust the color of the obstacle, check its anchor properties, and uncheck its gravity and collision properties. You can design different obstacles according to the content of your game. Once we have designed multiple obstacles, move these obstacles farther away from the game region. This is to prevent players from being able to see the obstacles we have prepared in the game region. Then create a new folder in the Game Resources view and change the name of the folder. Do not overlap the name with other nodes. We put all the obstacles into a folder, which will be used as the parent node of the obstacles. Next, we will implement the logic to continuously generate obstacles. Click Game Settings, select Triggers and Scripts, and open Server Script Management. Create a new server script and rename it to Obstacles Factory. Double-click to open the script. First, define a module Obstacles Factory. Next, define some variables. The current map variable is used to store the player's current map. The start position variable indicates the position of the generated obstacle. The end position variable indicates the end position of where the obstacle moves to. The interval position variable indicates the distance that the obstacle moves each time. The obstacle's root variable indicates the folder node where the obstacles are stored. The obstacles table variable is used to store the generated obstacles. The create time variable is the amount of time to wait for each obstacle to be created. The unit of measure is in frames. The timer variable is used to store the created timer object. Define another externally accessible startup function that takes one parameter, which is used to pass the map where the obstacle is located at the time the obstacle is generated. Assign this parameter to the current map variable. The FindFirstChild function in the root property of the map is used to get the folder node where the obstacle is stored. After getting the node, define a local function and call it in the startup function. Use this local function to handle the logic for generating obstacles. Get all the child nodes by using the getChildren function of the node. These child nodes are the previously created obstacles. Now, we have to choose one of the obtained obstacles at random to clone. Get a random index value by using the random function in the math class. With this index value, we can get a random obstacle. By calling the clone function, the obstacle can be cloned, also known as copy and paste. Assign the variable start position to the world position property of the new obstacle. Place the new obstacle under the current location map node. Change the name of the new obstacle. Finally, the new obstacle is stored in the table where the obstacle's ID is the key, and the obstacle itself is the value. To be able to generate a constant stream of obstacles, each time we generate an obstacle, we instantiate a timer object with a predefined createTime variable, and the callback function is the function itself. Then just start the timer. After completing the code, open the server's main script. Use the required keyword to load the obstacle's factory module. Use the getStaticMap function of the world class to get the current map. In order to avoid that the game object is not yet loaded when the player enters the game, resulting in our inability to get the node where the obstacle is stored, we can start a timer and wait for 160 frames before calling the obstacle's factory module startup function. After completing the code, go back to the editor, run the game, and look at the results. You can see that obstacles appear, but the obstacles do not move. Next, let's complete the logic for the movement of the obstacles. First, we need to start a timer with 1 frame interval in the startup function. Then, define a local function, and have the timer call it every frame. We handle the logic related to the movement of the obstacles in this function. Because we will clone many obstacles, which all need to be moved, then we need to iterate through the table where the obstacles are saved to get all the obstacles, and then perform the movement operation on them. The obstacle movement effect can be achieved by increasing the coordinate position of the obstacle by some amount per frame. The specific logic is to increase the coordinates of the obstacle by a specified distance every frame, which can be done using the predefined interval position variable. When the obstacle arrives at the set end position, we have to destroy the obstacle. Then you also need to determine the distance between the obstacle and the end position. Use the distance function of vector3 to get the distance between the two, and then determine whether it is less than a certain value, for example, 0.5. If the condition is met, we think the obstacle has reached the end position, we can destroy it. To destroy the obstacle, we can call the destroy function. Otherwise, the obstacle will continue to move toward the end position. After completing the code, go back to the editor, run the game, and look at the results. You can see the obstacles start to move. However, we will find that the player went straight through the obstacles and did not back up. Next, let's implement the logic for player's fallback. Define a local function and call it in the startup function. We handle the collision logic between the player and the obstacle in this function. The editor provides 2 functions for registering collision triggers, namely, the register handler function and the add handler function of the trigger class. The difference between the two is that the register handler function overwrites the existing triggers with the same trigger name, while the add handler function saves all the triggers with the same name in the trigger queue, and calls the triggers saved in the trigger queue in turn. And when activated, you can choose the appropriate function according to the content of your game. Here we choose the register handler function. The register handler function has 3 parameters. The first parameter is the configuration information of the activated trigger object. Here we get the player's configuration information through the entity getConfig function. The second parameter is the trigger name. Here we use the trigger when the entity starts touching the part. The third parameter is the callback function to be executed after the trigger is activated. For more information, you can check the API documentation on the official website. The trigger callback function has one parameter. The object1 field of this parameter indicates the object that activated the trigger, which in this case is the player. The part field of this parameter indicates the part that collided with the player. We distinguish whether a player encounters a part as an obstacle by determining whether the name of the part matches the name of the obstacle. If it is an obstacle, then it makes the player fall back. For the player's fallback logic, this can be achieved by calling the setForceMove function of the entity object. This function needs two parameters. The first parameter is the target position of the move. The second parameter is the time elapsed during the move in frames. We let the player move a distance in 5 frames to act as an effect of the player moving backward. The exact code is written like this. After completing the code, go back to the editor, run the game, and look at the results. You can see that the player falls back a distance when touches the obstacle. This is all the content of this video. I hope this content can help you make better games. To learn more about the content related to the Rainbow Dash template, you can leave a comment below the video, or post it on the official forum. See you in the next video.